Perspective Class 7 Video 1. In this video we're going to begin talking about parallel projection. So in the most general form, parallel projection is a method for taking an n-dimensional object, where n can be any number, and mapping it down to an n-1 dimensional object. Or you can think about this as taking an n-dimensional object and mapping it into n-1 dimensional space. Okay. In particular, it takes three-dimensional objects and it maps them onto to a two-dimensional object. So it takes three-dimensional objects and maps them into a two-dimensional space. And this is the case which we're most interested in. But to warm up and to get a feel for what parallel projection is, in this video we're just going to consider the 2D to 1D case. So this is like the easiest case. It's like a warm-up case. So let's look at the definition. Definition says parallel projection onto the line x equals a is given by this formula, the formula in pink. So the coordinate x, y gets mapped to the coordinate a, y. And similarly, parallel projection onto the line y equals b is given by the formula x, y gets mapped onto the point x, b. And these are the formulas for parallel projection in 2 dimensions to 1 dimension. So this is parallel projection from 2D down to 1D. Okay. And how should you think about this? Well, it's got a really easy geometric interpretation. I draw some coordinates. So this is the x-axis, this is the y-axis, and I draw a line. So like this line right here. If this is the point 2, then this line is the line x equals 2. Okay, it's all the points in the xy plane where the x value is 2. And how does parallel projection onto this line work? Well, if you have a point, this point here, all you do is you parallel project it onto the line. So if you have this point here, you draw a line like that. So all the arrows are hitting the line perpendicularly. Okay, so it doesn't matter what point you start with, same technique. So I'm saying this point gets mapped to this point. Like algebraically, what's going on? Maybe this point here is the point 5, 1, and it gets mapped to the point 2, 1. This point here is the point what is this, 4, 2, and it gets mapped to the point 2, 2. And finally this point here is this point 6, 3, and it gets mapped to the point 2, 3. Okay, this is parallel projection. You just take whatever point, you draw a line perpendicular to the red line, the image line, and then you drop the arrow. Okay. So this is parallel projection onto the line x equals 2. And I'm not going to do a whole new example, but it's very analogous to do parallel projection onto the line y equals something. So if I quickly draw something else, and maybe this is the point 1, so that means this line is the line y equals 1, then now the points just project downwards or upwards, depending on their relative position to the line. Okay. So one way to think about this parallel projection is if you have some like two-dimensional figure, what you're doing is you're literally just squishing it into the red line. You're just like completely flattening it into the red line in a parallel way. So all of these arrows are parallel. Okay. Let's look at some algebraic examples. So this example just asks you to complete the following table. I give you a bunch of points, and I want in this column here you to parallelly project them onto the line x equals 1. And in this column here, I want you to parallelly project them onto the line y equals 2. Well, it's really simple. To parallel project onto x equals 1, you just replace the x coordinate with 1. So this is 1, 3, this is 5, 3, this is, oh wait a second, this is 1, 4, This one here is 1, 4. And the last one, it's already a 1, so nothing changes. It's 1, 0. All you do is you replace the x coordinate with a 1. Okay? And notice sometimes two different points actually end up going to the same point under parallel projection. And that's okay. I mean, if you think about our picture, what that would look like is, you know, if I map this point and this point, they both end up going to the same place. So they both end up going down here. And that's what happened here. Both of these points ended up going to the same point. So let's move on to the parallel projection onto the y equals 2. Now all I do is I take my original point and I replace the y coordinate with 2. So it's going to be 2, 2, 5, 2, 3, 2, and 1, 2. And that's it. Okay, this is parallel projection from 2 dimensions onto 1 dimension. That's the end of this video.